All right, so this is the mixed practice for the triangles test, which is going to be on November 30th. All right, so the first one says, if triangle CAB is congruent to triangle DFE, complete each statement. The biggest thing about these ones is whatever order the triangle vertices go in, they are going to hold correspondence. So when we start looking at A, this first letter says, question A. When we see that first one is A, I have to figure out what point from DEF is going to correspond to A. So whatever comes first, so C is going to correspond to D, A is going to correspond to F, and B would correspond to E. So then I can see that A is in the middle, so that's going to correspond to F. And then I see that E is last, so E is last is going to correspond to B, which means that the only letter left from A, B, C is C. So then the last letter over here, I can see that C corresponds to D. So then all of these will hold the same. B is last, it corresponds to E. D is first, and it corresponds to C. And I can see that the last one will be A, which corresponds to F. So same thing with angles. A is in the middle, which means its corresponding angle is the one in the middle as well. So that's going to correspond to angle F. Angle B is last, so that's going to correspond to the last one from DFE, which is going to be angle E. And so for here, these matter in terms of how you're naming them. So like this first one says segment AC. So if I'm starting at A and going to C, that corresponding segment would start at F and then go to D. So they are going to have to go in the same order. And so for CB, it would be the same from C to B, would be the same from D to E. So those would be for that one. All right, so number 2 says for each pair of triangles, determine whether or not they are congruent first, and then if they are, then you can complete the congruency. And give the postulate or theorem that justifies your answer, and then if the triangles are not congruent, you can write not congruent. So I'm just going to make a chart. So congruent triangles and not congruent triangles, I know that the only two that are not are AAA and then SSA, but SAS, AAS, SSS, and ASA, and also HL are all going to be congruent ones. Thank you. So for this one, if I look at these two triangles, I can see that it only has sides marked, not angles. So I know that these are going to be congruent by side, side, side. And so to figure that out, PQR. So if I start at P and travel across the 2 tick mark side to Q, and then travel across the 1 tick mark side to R, I have to do the same thing over here. So then starting between the 2 and 3. So I'm starting at T, traveling across the 2 tick mark side, and then traveling across the 1 tick mark side. So that would have to be triangle TWX. So HEG, the biggest thing on these two is hopefully you guys recognize that there's vertical angles right here. So for that one, you'll notice that it has the angle and then the included side and then that second one. So that one's going to be angle, side, angle. And so for HEG, so starting at the 1 ticked angle and then going to the non-marked angle and then traveling inside to that vertical angle. So in terms of naming this one, I'm going to have to start at that 1 tick mark angle, travel to the non-marked angle, and then travel back into that double tick mark angle. So this one would be triangle FKG. All right, so then this one, okay, so this one kept confusing a lot of people. If you look at the 2 different triangles, one triangle looks like this, and the other triangle looks like this, the ones that are overlapped. So these congruency markings for the angles are just going to be these angles on the outside. I can see that these ticked mark sides are going to be these ticked mark sides on the other side. And then you can see that SK right here is the shared side. So the SK on this triangle is the exact same SK from this triangle. So if you look at that, you have side and then the included angle and then the side. So that one's going to be side angle side. So it says SKJ. So starting at S and traveling out to the other end and then traveling out to J. So to go backwards, I would start at K, go backwards to S, and then I can go out to that last point C. So that would be triangle KSC. Again, on this one we have vertical angles. So a lot of people think that since this one has a right angle, it's supposed to be HL. So it does give us that we have congruent hypotenuses, but it does not have anything about the angle right there. But I do end up having the side and then an angle, and then that next angle is 90 degrees. And again, I have the side, the one ticked mark vertical angle, and then that 90 degrees. So I think that this one's going to end up being side angle angle, or you can put angle angle side. Both of those are the same thing. So to name ABC, I'm starting at A, going to the right angle, and then going to the vertical angle. So then I'll have to start at E, traveling to the right angle, and then travel to the vertical angle. So triangle EDC. All right, so this one I see that it's a right triangle, and there's no other like vertical angles or anything. So you know that AE is congruent to AE because of the reflexive property. So the triangle on the left and the triangle on the right have two things. So you'll notice that technically this would be the side and then the side and then the angle, but that's the one that's a bad word. That is not a true congruency. So anytime you have those right triangles, you want to look for HL. So we do have the congruent hypotenuse, and that shared leg is the same. So these are going to be congruent by HL. So we can say that GEA is going to be congruent to MEA. On that one. Down here we have vertical angles, 1, 2, 3, 1, 2, 3. So this is angle, angle, angle. So a big thing that, make sure that if you see that something's angle, 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 you should not be putting it in the congruency statement at all. All I know is that this triangle is not congruent to anything else. You do not have to put what theorem, because it's not a congruency statement. So all you have to do for that is put not congruent. So 9, CAT. So again, I can see that CT is shared right here in the middle. A lot of people think that this one's hypotenuse leg as well, but notice that S and A are not right angles. They're just congruent angles. So again, we have that SSA, which backwards is that bad word. And since it's not a right triangle, I cannot use HL. So this one is just simply not congruent. So a lot of people think that this one is going to be AAS because they share this side OY right here. But if I was to reorientate these and like draw two triangles, so like if I had two triangles, I want to split them up. If I look at just triangle JOY, if this is my 90-degree angle down here, I can see that right above would be that ticked mark side, and the double ticked mark side is down here next to the 90-degree angle. It's not the one that's in between. But if I was to draw this triangle, SOY, you'll notice that its 90-degree angle is right here. This one looks exactly like this one, and then the ticked mark angle is up top. But notice that the shared side is the side in between those two angles, which is not the same side on both of those angles. So since it doesn't go in the right order for both, this one is also not congruent. All right, so if triangle ABC is congruent to triangle PQR, so it tells us AB is a certain expression, BC is a certain expression, and PQ is a certain expression. So it wants us to find X and AB. So in terms of AB, I can see that AB right here is going to correspond to PQ. So it does give me AB, but we're not going to use BC. We have to use PQ because those AB and then PQ, right? So correspondence. So we know that we can take the AB side and set it equal to the PQ side since they're congruent. And then I'm just going to solve. So minusing that x squared over would be an x squared. Minusing these 8x overs would be negative 14. And then plussing these 6 over would be a positive 24. And then everything's set equal to 0. So then I'm trying to find the two numbers that multiply to positive 24 and add to negative 14. Those are just going to be negative 12 and negative 2. So if I set those equal to 0 and solve, we end up getting a solution of 12 and 2. And I'm pretty sure both of those work, so you are just going to end up having two answers. So x could be 12 or it could be 2. So to find AB, I'm going to have to find two answers. So AB is 2 times 12 squared squared minus 6 times 12 plus 18. So if I use a 12, then AB is 234. Or if I do the whole thing with a 2, then I get that the answer is 14. So 2 different answers on this one. They both work out. Since AB is a side length, both of these are positive. They both work out. All right, so for each of the following, we are going to state the conclusion that follows from the given information and then support it with an appropriate reason. A big thing is make sure that you guys draw the pictures as well. When it says angle A is congruent to angle B and angle A is congruent to angle C, you don't need any special picture. I just want to talk about angle A is congruent to angle B. The way that I mark them congruent would be those congruency markings. And then it's telling me that A is also congruent to angle C. So that means that whatever this angle measure is, it would have to be the same angle measure over here. So always that first line is given. So since I know that A is congruent to B and A is congruent to C, the way this works is like you have statement 1 is equal to statement 2, and also statement 1 is equal to statement 3. So since you have statement 1 that's equal to 2 different things, I can also state that angle B, statement 2, is congruent to angle C, which is statement 3, and this one's going to be by substitution. If it would have said angle A is congruent to angle B and angle B is congruent to angle C, then you could have concluded that angle A is congruent to angle C. That would have been the transitive. So just make sure that you know the difference between substitution and transitive. Transitive is when those 2 inside ones match. Substitution would be where it's like, again, statement 1 is equal to statement 2, and also statement 1 is equal to statement 3. This one looks like statement 1 is equal to statement 2, and statement 2 is equal to statement 3. So those 2's match on the inside. Here, 2 and 1 don't match, so that's kind of how that goes. All right, a big thing that I saw on the quiz too is a lot of people turn triangles into angles and angles into triangles. If it's talking about angle PRQ, then you need to draw an angle. It does not need to be a triangle. So angle PRQ. And it tells me that a segment RT is going to bisect the angle. So that means that angle R right here is going to get bisected, which means that these 2 angles are going to be congruent. So always we are writing that first one as given. But as soon as I know that RT bisects, that tells me that those angles are congruent. So therefore, I can logically say that angle PRT is congruent to angle QRT. And then the reason for that would be if angle bisector, then congruent angles. All right, U is the midpoint of BG. U is a point since it's not talking about an angle or a line or anything like that, but BG is a segment. So then I can go ahead and draw segment BG. And it's telling me that U is the midpoint. So that's really all I know. U is mid. And that is our given statement. So since that's the midpoint, I know that both of those sides are going to be congruent. So therefore, I can state that segment BU is congruent to segment GU. Notice that again, if I'm going to start at the endpoint and travel to the midpoint in terms of naming it, then I need to start at the other endpoint and travel into the midpoint to name it, so from G to U. And the reason that I know that is if segment midpoint, so I'm just going to put midpoint. If midpoint, then congruent segments. So I think a lot of people might skip and just straight go from RT bisects it, then you can state congruencies, but you have to say why, how you know that. All right, so ABC is equilateral. So again, it has a triangle, so that's how I know that this is supposed to be triangle ABC. And so equilateral triangles, we know we can make these markings. ABC is equilateral, that is given. And so, therefore, I can conclude that the side AB is congruent to the side BC, is also congruent to the side AC. And the reason and that's just kind of like definition of equilateral triangle. Since it said equilateral, lateral is talking about those legs, so that's why we're going to talk about the legs, not necessarily the angles first. All right, so the next one, these are always like a big problem, the parallel ones. So AC is parallel to BD. So whenever it comes to parallel lines, you should always be looking for alternate interior angles. So for here, this would be my transversal. Angle 3 and angle 7 would be those alternate interiors. Or you could also look at it from the other direction using this transversal. Would mean that angle 2 and angle 6. And the reason I know that is if two lines are parallel, then alternate interior angles are congruent. So that's typically when it talks about parallel lines, that's what you're looking for, alternate interior angles. All right, so this last one, I'm not going to fit all that in there, but we're just going to pretend that we wrote the given statement down there. Angle 1 and 2 are vertical angles. By definition, these would be angles 1 and 2. And the whole point of vertical angles is we know that if they're vertical, then angle 1 is congruent to angle 2. And that's just because if we have vertical angles, then the angles are congruent. All right. So then this one says, name the algebraic property being illustrated. Whenever you have the exact same thing on both sides, that's reflexive. So this one, it looks like they got rid of that negative 16 and they simplified the other side to be 36. So they plussed the 16 over. So that means that they added on both sides, so addition. T-island. All right, so this is the one that's talking about, like, so if statement 1 is congruent to statement 2 and statement 2 is congruent to statement 3, then I can just jump straight from statement 1 to statement 3. That's going to be transitive. So here it just looks like the order, they did x plus y and then they switched it to be y plus x. It's not changing anything since they just switched the order. That's going to be the commutative property. And since they're adding, it would be the commutative of addition. All right, so it looks like from this quadratic to this quadratic, they just divided everything by 2. But division is not a property, so that would have to be multiply by 1/2. Or multiplication, whatever you want to write. All right, this one says if 3 equals x, then that's the same thing as a equals 3. A lot of people get this one confused with the reflexive property, but notice that they switched the order. Like 3 was originally on the left side of the equal sign. Now the 3 is on the right side of the equal sign. When they switch the sides that things are on, that's going to be symmetric. All right, so for this one, they gave us an expression and told us that x is 25. So then they went and actually used that 25 in there. So I think that that's going to be substitution or simplify, since they kind of did both in once. But I don't think you'll have one like that that has like two kind of options. All right, so this one, it looks like it said x plus 4 plus y equals 12. And all they did is inside this first set of parentheses, switch the order that they added. X plus 4 is the same thing as 4 plus x. So since they just switched the order, that's going to be commutative of addition. And then a lot of people on the quiz got this one wrong. Whenever you have 3x and 4x on the same side and you're just putting those together to be 7x, that's going to be combined like terms. A lot of people said that this one's addition because you're adding the 3x and 4x, but addition would be if I'm adding something to this whole side and to the 21 side. I'm not adding anything to the 21 side. It's still 21. It's just that these like terms that I have, I'm adding them together. That's just combining like terms. It's not adding. Again, adding would be adding to both sides. All right, so for this one, originally the parentheses are around the x plus y and then plus z, but over here they associated the y and the z being added together. So everything's going in the same order, x plus y plus z, x plus y plus z. So it's not that they switched the order, they just changed the parentheses. So they're associating different letters together. And if you just look at the symbol, it should just be associative of addition. All right, so for number 6, these proofs, I'm just going to do them on an index card. All right, the biggest thing for proofs is that you have to make sure that you do your 2 statements, your 2 columns. All right, so for this first one right here, we have our statement and our reasons. So the first thing is I'm going to pretend that I copied all of that down, but that's going to be given. Okay, maybe I'll do it. CB is parallel to AD. All right, so what does that tell me that CB is parallel to AD? So CD is parallel to AD. So I think that means I have some alternate interior angles. So I think, let's go, okay, let me actually keep going. So let's see, we know that angle 1 is congruent to angle 2. It also tells me M is the midpoint of AB, so M is in the middle, so then this is congruent to this. Okay, so I think that if I look at this, I already have an angle and a side. It tells me nothing about that extra side right here, but the whole point of those parallel segments, again, is that I have those alternate interior angles. So we can look at angle B and angle A would be alternate interior angles. So since those are parallel, I know that angle A is congruent to angle B. And the reason I know that is because if lines are parallel, then the alternate interior angles are congruent. So that's the first thing. Another thing that I was given that I didn't write down yet, though, is I know that M is the midpoint of AB. That's given. And what I know about that, that tells me then that segment AM has to be congruent to segment BM. And that's if midpoint, then congruent. We also know that angle 1 is congruent to angle 2, and that's just if vertical angles, then those angles are congruent. So we have officially proved that one angle is congruent, one side is congruent, and then that other angle is congruent. So that kind of lets me know what, that kind of lets me know what I'm going to be going through on here. So officially, once I get all of that, then I can go ahead and conclude that triangle. Okay, so how do I want to name this? CBM would be congruent to triangle DAM. And the property that I used for that, or the congruency, would be angle, side angle, we said. So really, though, if I look, it didn't even want me to prove anything about the triangles. It wants me to prove that M is the midpoint of CD. So now that I know the 2 triangles are congruent, the next thing I know is that all of the since they're congruent, remember that corresponding parts of congruent triangles are congruent. So as soon as I know that the triangles are congruent, that means that every corresponding part is congruent as well. So notice that if I look at that triangle, that segment CM is going to correspond to that segment DM right there. So then I can go ahead and say that CM is congruent to DM, and that's because corresponding parts of congruent triangles are also congruent. And since that means that since I know that those 2 segments are congruent, then I do know that M is the midpoint. And the reason I know that is because if midpoint, then congruent. So that was for 6A. All right, 6B. I'm going to make my columns. I have my statement, my reason. And so for this one, I think we're going to have to draw a picture for ourselves. All right, so segment BD bisects angle ABC. So angle ABC, ABC is D. So bisect means they're congruent. So it tells me ABD. So this angle up here is 9x plus 1, and then it tells me that CBD is 7 times x plus 1. All right, so the first thing is we know that BD bisects angle ABC. I know that the measure of angle ABD is 9x plus 1, and I also know that the measure of angle CBD is equal to 7 times x plus 1. And all of those are given. So the only thing that before you can start talking, like we already know that bisected means that those two angles are congruent, so I can set those equal to each other. But before I can ever write that down, I need to say why. So I know for sure that angle ABD is going to be congruent to angle CBD. And the reason I know that is because of that bisects up there. So if bisect, then congruent. So now that I know that those are congruent, now I can set them equal to each other. So I know that for ABD, we already said that that was 9x plus 1. That has to be exactly equal to CBD, which is, we said, was 7 times x plus 1. And that's going to be by substitution. I'm substituting the expression for what the angles were. So then the next thing I can do is distribute that 7 over there. So I get 9x plus 1 equals 7x plus 7. That's distribution. I'm going to do 2 at once. So if I minus these 7 x's over, I'm left with 2 x's. And if I minus that 1 over, I'm left with 6. And the reason I can do that is because I'm adding a few things to both sides, so addition. And then from there, I'll divide both sides by 2. Tells me that x equals 3, but that's actually going to be by multiplication. Like multiplying by 1/2 on both sides. So then this one wants us to prove actually that angle ABD is equal to 28 degrees. So I'm going to have to fit one more line after this. So if it's talking about ABD, we already know that angle ABD is going to be equal to 9 times x, but now we know that x is 3 plus 1. And that's going to be by substitution. And then the last step after that, so step 8, would just be that angle ABD is equal, so 9 times 3 is 18 plus 1 more, I'm dumb. 9 times 3 is 27 plus 1 more is 28. So that would be 28 degrees. And the reason that I can say that is by simplifying that answer. A lot of people said on the quiz that this step right here was multiplication. But if you multiply, again, you have to multiply both sides. I'm not multiplying this left side by anything. That's just a statement. Only these two numbers. So that would just be simplify. All right, and then the last one for here is going to be 6C. All right, so first I know that angle A and angle C are right angles, and I know that AB is congruent to BC, and those are all given. So now I'm going to go ahead and mark it. So A and C. And then AB is congruent to BC. All right, so this is all that's been given to me so far. So as soon as I see that both of these triangles have right angles, that tells me I know for sure that this also has to be a right triangle by definition. So I'm going to go ahead and say that. I know that triangle, okay, so let's see, BAD and triangle, okay, BADCD, no, BCD are right triangles. And the reason I know that is, I guess just definition of right triangle. A right triangle has to have one angle that's 90 degrees, which would be that angle A and that angle C. All right, so the biggest thing I know on this one is if you have a right triangle, you kind of want to look for HL. We also know that BD is reflexive right there. So we know that the segment BD is going to be congruent to segment BD, and that's reflexive. So I think we do end up having a right triangle, and so remember the hypotenuse is always across from that 90-degree angle. So we do have a shared congruent hypotenuse, and then we have one leg that's congruent. So therefore, we can go ahead and state the congruencies for these. So then I'll go back to triangle BAD is congruent to triangle BCD, and that's going to be by HL. But again, that's not even what it wants us to prove. It wants us to prove that BD sects angle ADC. That BD bisects ADC. So bisect, so it's trying to get us to prove that these angles are congruent. Well, the same way, if I know the triangles are congruent, that means that every corresponding part also has to be congruent. So as soon as I know that, I do know for sure that these two angles are congruent. So ADB, angle ADB, is definitely going to be congruent to angle CDB because corresponding parts of congruent triangles are also congruent. So once I know that every single part of the triangle is congruent, then I can say that anything is congruent. So then that tells me that, yeah. So then since I know those two angles are congruent, then I do know that BD bisects angle ADC. And so again, if bisect, then congruent. If it's congruent, then it got bisected. If it's bisected, then it's congruent. All right, so number 7 says you can create your own congruent triangle using a coordinate grid. Which of the ordered pairs below could be used for point L so that triangle ABC is congruent and corresponds to triangle JKL? So the big thing on this one is you'll notice that it gives us JK and it gives us the ABC down here. So we're trying to figure out where does L have to go. So notice that L is connected to that point K right here from JKL, which means that KL is going to have to correspond to BC right here. So I have to figure out how long BC is, and then KL will have to be the same thing. So BC is 1, 2, 3, 4, 5, 6 units long. So what that means is that the segment KL is also going to have to be 6 units long. We know BC is 6. We have to make sure that KL is 6. So you'll notice that I have to start at K and count out 6. 1, 2, 3, 4, 5, 6. So I think that point right there is going to be that point 8, 2. So that would be KL, and that would be a triangle. Or notice that I could go backwards, 1, 2, 3, 4, 5, 6. And I could swing that out from K, and that could also be KL, which would be negative 4, 2. Notice that if you use those other 2 points, those 2 points are going to make triangles up here. The reason that these points do not work is because notice that this unit that's 6 right here, this would be L and L. That would be the segment JL. JL, and that's not what we're trying to match over here. We needed KL to match BC. So that's why it has to start from K to L, start from K to L. You can't use those ones up top. So why do some points work and some others don't? Not same congruency order. All right, so number 8 says create a congruent polygon to quadrilateral LMJK. Oh, create a congruent polygon. It's telling us that we have quadrilateral LMJK, and we need it to be congruent to quadrilateral XWYZ. All right, so when I look at this one right here, I'm just going to write a few things. I like color coding. I need to do this. All right, so I know that LM is going to have to correspond to XW. All right, so there's my XW. I also have WY right here. WY is going to correspond to MJ. All right, so that's that one right there. And then we have to figure out where the other two side lengths are coming from. So then, okay, sorry. So to get from J to K, we're going to have to count the slope. So I'm going to go, starting here, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So down here from Y, so again, we went up 8 and then over 10, which means I'll have to do the same thing here. But instead of going to the right to get to K, I'm going to have to go up and go left to get that other point. So then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be that point right there. And so K is going to correspond to Z, so that has to be point Z, and then I could go ahead and connect those points, and then I could get those two congruencies. Good luck on your test tomorrow!